Hello everyone, welcome to Green Bionomy. This video is about atoms and elements. So it's a bit outside of the usual subject of hydroponics and gardening, but as I was researching for plant nutrients like nitrogen and potassium, I was always wondering, but at most fundamental levels, what are they? And I realized that there was a big foundations that I skipped in my learning to understand how the plants actually live and interact with the world around it, and basically of what is composed this world in which the biological world exists. And this led me to the physics and chemistry of the world, and ultimately trying to understand what is an atom and what is an element and what is the difference and the link between them. So this video is about the foundation, really to lay down this foundation we will need to understand most of the other complex biological systems and phenomena that we will see later on as we advance in hydroponics and gardening, or even in ecosystems, and just understanding what is the world around us. So hope you enjoy it and the video is useful for you as it was useful for me. At the beginning, we have matter. What is matter? Matter is anything with a physical body that takes up space. So, if it has a physical body, it takes up some space around you, that is matter. And it can be in either three states. It can be a solid state, a gas, or a liquid. But in any case, it will have a physical body and it will take up some space. Now, if we take this cube, for example, it has a physical body and it takes up space, therefore it is matter. If we break down the cube and we break it down again, and we keep on doing that, ultimately we will arrive to something that for a long time we thought we could not break anymore. And this is what we call an atom, right? And the atom is considered the basic unit of matter. Okay, so we have the atom and it's considered the basic building block of matter. So we took the cube, we break it down, and in the end we arrive at an atom, which is basically what is making up the cube. Okay, now not all atoms are the same. Atoms can have different properties and behave in different ways. For example, if our cube was a cube of gold, it will be heavy, it will be a bit yellow, it will be a bit shiny. But if it was a cube of carbon and you break it down just like we did until you reach to an atom, you start with a cube of carbon, but in the end, when you break it down enough, you end up with an atom of carbon. Or if it was a cube of gold, you will end up with an atom of gold. But these two will be different, right? One will be yellow, the other one will be blackish, another one will be heavier, the other one will be lighter. So it behaves in different ways. They have different properties. And so to be able to categorize all the different atoms that exist in the universe and that is around us, we started talking about elements. So the elements are the types of atoms that exist around us. So basically everything that is around you is matter made of atom, and these atoms all have different types, right? It can be the same type, but they can also be of a different types, and these types of atoms are the elements. And all of these elements have specific properties that are unique to the atom in question, and that's why it's considered an element in itself. And there are 118 elements identified today in the universe. There might be more, but right now that's what science managed to identify. So everything around you and in the universe is made of these 118 elements. Okay? Now, why are atoms different? What makes one atom behave in a certain way and the other atom behave in a different way? This is because there is something else inside the atom, and that's what we call fundamental particles. These are the particles that are inside the atom. So contrary to what we used to think, the atom can be broken down, and if you look inside the atom, you will find neutrons, protons, and electrons. Okay? So these particles make the atoms, and depending on the quantity of these particles in the atom, the properties will change. But out of the three, the most crucial one are the protons, because the number of protons in the atom is what is going to define the element to which the atom belongs. This is very important because the number of protons, if you change it, you change the element. Okay? If we look, for example, at a carbon atom, it has a specific number of protons in it, and if you change that number of protons, it won't be a carbon atom anymore. So that's the main characteristic that will define the element. Now, the neutrons and electrons, you can change their quantities, but it will stay the same element. It will just become another version, a variation of the same element. Okay. Now let's try to visualize all of this. Okay. This is a 3D model of an atom. So it's a simplified version of reality. And reality does not look quite like this, but this helps us have a first mental model of how it behaves. So in the center, you have the proton and the neutrons together. Okay, inside the atom. That's the center, that's the nucleus, that's the core of the atom. And around it, you have the electrons. So they are not rotating around, they're more like buzzing around, but this again is a simplified version of reality. So that is what the atom kind of look like. Now, if we take the info card of an atom, let's say a carbon atom, it will look like this. So when you look at the periodic table, if you Google periodic table and you look at that really scary table that you always like, oh my god, this looks so hard, I don't want to look at it. It's actually quite simple when you take the time to understand what is going on in there. So each element will have its little info card. Okay, on top you have the atomic number. This atomic number is the number of protons inside the atom, and that's what determines the element, right? It's because carbon has 6 protons that it is the carbon element. That's the defining characteristics. Then you will have the symbol below the atomic number, and sometimes you'll also have the name of the element. Now, let's say we want to add 1 proton to the carbon atom or element. Well, we won't have a carbon atom anymore. It will become a nitrogen atom. The element will change, okay? And if we remove a proton, then we will have boron. So that's not carbon anymore because now it has 5 protons. And this will be represented by the atomic number. So boron will have the atomic number 5 because it has 5 protons. Carbon, atomic number 6 because it has 6 protons, etc. for all the 118 elements that exist. Now, let's look at a 2D version of an atom to try and understand it even better, what is going on, and not going in depth, but just to change the angle of approach. So we will look at a carbon atom. So as we saw in the center, so the 3D model is not a carbon atom. I actually don't know what atom is that. I just wanted a 3D version so that you can look at it and see, okay, that's kind of what an atom look like in 3D. But I don't know what atom is it, okay? But now we're going to look at a carbon atom specifically. So in the center, you will have the proton. All right, the proton always will have a plus on them in the drawings and the models because they have a positive electrical charge. Now, with the proton in the center, you will have the neutron. The neutrons, as their name indicate, they have a neutral electrical charge. They are not charged. All right, and around them, you will have the electrons buzzing around with a negative charge. So these charges are kind of important because basically the positive and the negative attract each other, and that's why the electrons don't go flying somewhere else. They're attracted by the center because the protons are positive and the electrons are negative. Now, again, that's a simplified version of an atom, right? But all of that is to help having a representation of what is going on. And you can see, if you count them, you can see that the carbon atom has 6 protons. If you change the number of protons, you change the atom. You won't be talking about carbon anymore, you will be talking about something else. So remember, you have the atoms, and each atom has a type, and the type is called the element. And in that case, the atom here is of element carbon because it has 6 protons. Now, something else that is very interesting to know, and that will be very useful to understand what is going on later on, is that electrons can travel between atoms. So an atom can come and steal an electron from another atom, or they can trade electrons, they can do things like that. So electrons can move from atoms to atoms, and that is what will form the basis of the interactions between the atoms. That's why the atoms can interact. That's why the atoms can do other things than just being themselves and just being of this one pure element. Okay, it's because the electrons can travel between them. Something else that I think is important to know and helps making sense of all of that is that the atom, in a way, can still be considered the basic building block of matter because it is the last level until you lose the properties of the element. Alright, so matter do things because it has certain properties, and these properties appear when you have an atom. But if you break it down and you just get neutrons, protons, and electrons, you lose the properties of the elements, and that's why it's still important to have the atom as the basic building block, because that's where, well, matter starts to do certain things that we classified into elements. So that's it. We just stop here, and that's just to lay down this very important foundation, because that's something for a long time I've been always wondering. Okay, like if we're talking about, so here we're talking about plants, right, of hydroponics, gardening, and now we're talking about nutrients like nitrogen, phosphorus, and I've always wondered, but what are they? What are these things, right? And to be honest, I completely skipped the physics class and I don't remember much, and the chemistry classes, so I don't remember much. So this is just to try and have a simplified version of what is going on. So as a summary, let's go through it one more time. So we start with matter. Matter is basically anything with a physical body that takes up space, and the basic building block of matter is the atom. Now, there are different types of atoms, and the difference between the types is based on the specific properties of the atom. And they are classified in elements, and there is 118 elements around. Now, atoms behave in different ways because inside the atoms you have fundamental particles, which are neutrons, protons, and electrons, and based on their quantities in the atom, the properties will change, and the most crucial one is the protons because it's the defining characteristic of the elements. If you change the number of protons, you change the element, but if you change the number of neutron or electron, you just created a variation of the same element. Okay, that's pretty much it, and I hope the video was useful for you in a way. If it was, leave a like, subscribe, leave a comment, and I will see you next time. Bye bye.